Hello students, welcome you all. In my today's lecture, I will discuss about the organometallic compounds. Organometallic compounds, for example, organomagnesium compound, organolithium compound, organo copper compound, organocadmium compound, organomercury compound. So these all compounds, if you will see, then this carbon is bonded to one of the metal. Okay, so organometallic compound, it can be defined in a single line, that is compounds having carbon metal bond. So these are the compounds having carbon metal bond. Okay, so for example, if we have this carbon, and this carbon is attached to one of the metal. Now, if we see the electronegativity difference between this carbon and this metal, then we know that the electronegativity of this carbon, this is 2.5, whereas the electronegativity of metal in organometallic compound, this all metals in organometallic compound is having the electronegativity less than 2.0. Okay, so such compound are called as the organometallic compound. Now, usually what we have read in organic chemistry. So we have read the carbon which is bonded to either oxygen, carbon which may be bonded to suppose nitrogen, or it may be bonded to some halogen atom, like this. So here all these atoms, these are the electronegative atom, and this carbon is, we can say the carbon is attached to some more electronegative atom. Here also carbon is attached to more electronegative nitrogen. Here also carbon is attached to more electronegative halogen atom. So in all such compound, if you will see, then this carbon is one of the electrophilic center or electron deficient center. Okay, so that's why the nucleophile may attack over this carbon. So for example, if we see this carbonyl compound, so this is also electron deficient compound. Nucleophile can attack over here, or some other nucleophile, maybe some either substitution reaction or this nucleophilic addition reaction may take place over here. But in this case, if you see, this carbon is having higher electronegativity in comparison to this metal. So that's why this carbon is having partial negative charge, whereas this metal is having the partial positive charge. So what we can say that this carbon is nucleophilic. So here this carbon, whereas in all other organic compounds, this carbon is having the delta positive charge and electrophilic in nature. So this is the nucleophilic in nature. Okay, so this is nucleophilic in nature. So here this carbon may act as a nucleophile, or it may act as a base also. Okay, so here it means in organometallic compound, the organometallic compound may act as a nucleophile or it may act as a base. So some of the example of this organometallic compound, well known example, for example, and this RMgX. Okay, where this carbon is bonded to the magnesium atom, and similarly if we see this R lithium. Okay, so carbon is bonded to the lithium atom. Similarly, this organocopper compound, which is okay, and others, for example, this carbon may be attached to the cadmium, carbon may be attached to the mercury, and so on. So if you see out of these, then here the electronegativity difference between this carbon and this lithium is the highest one. So lithium having the electronegativity of around 1.0, this magnesium is having the electronegativity of 1.2, and here this copper is having the electronegativity of 1.9. So if you will see, then which bond is more polar? So this carbon is 2.5, 2.5 and 2.5. So the most polar bond, this organolithium compound, organolithium is the most polar bond. So that's why if we see, then this organolithium is more reactive than organomagnesium compound, than this organocopper compound. Okay, so this is called as the, all of you know, this is called as the Grignard reagent, well-known Grignard reagent, and which is named after the scientist Victor Grignard, and he was a well-known scientist at that time, and he was given the Nobel Prize in 1912 for the discovery of this Grignard reagent. Okay, so, and this organocopper compound, or this is also called as the Gilman reagent. This is also known as the Gilman reagent. Okay, so we compare the reactivity of this. So this bond being the most polar bond, so that's why organolithium compound is the most reactive out of these three. Okay, so what I have told you, these organometallic compounds are the compounds having carbon metal bond, where the electronegativity difference between this, if you see then carbon is the nucleophilic center here, and that's why it may act as a base here. So what I can write, this organometallic compound, these compound may act as nucleophile as well as base. Okay, so now, so it may, because it may act as a base, and it is very strong base, it acts as a very strong base. That's why even it can react with some of the weak acid also. For example, it may react with water, it may react with alcohol, or it may react with acetic acid, like this. So as this Grignard reagent or this organometallic compound, so these act as, since as they act as strong base, so that's why they give the acid-base reaction. So, and we know that this acid-base reaction are very fast reaction. So as they act as a strong base, so it may react with weak acids, for example water here, or some alcohol, either ethanol, methanol, or acetic acid. It may react with acetic acid, it may react with this amines also, which may act as a weak acid. So these, if you see, then these weak acid, it contains this acidic hydrogen atom, means it react with this Grignard reagent or organolithium compound, that can react with any solvent. So this act as a solvent, this is one of the solvent, even this act as a solvent. So it can react with a solvent which is having this replaceable hydrogen atom, which is having the acidic hydrogen atom. Okay, so that's why when we prepare the Grignard reagent or some of the reactions with Grignard reagent are always carried out in solvent which is not having the acidic hydrogen atom or solvent which is free from acidic hydrogen atom. Okay, so this is one of the important point. Okay, so as they react with weak acids, so the preparation of Grignard reagent and the reactions of Grignard reagent and the reactions of Grignard reagent is carried out in presence of acid or in presence of solvent free from acidic hydrogen. So some of the solvents, so we have read that some of the solvents which are free from acidic hydrogen, so if you have seen, then always the preparation of Grignard reagent or reaction of this Grignard reagent, they are carried out in ether, diethyl ether. So this diethyl ether, this is not having any acidic hydrogen atom. So for example, we may write diethyl ether or tetrahydrofuran. The reaction is carried out in presence of tetrahydrofuran. Okay, so the Grignard reagent, if you are taking the Grignard reagent, it will always react with water. It can always react with alcohol or acid. So that's why the reactions of this Grignard reagent are always carried out in presence of ether or this tetrahydrofuran. So some of the reactions, we will see some reactions where this Grignard reagent act as a base. Okay, so let's see some reactions where Grignard reagent act as a base. Okay. Means what I told you, the Grignard reagent, either it may participate in as a nucleophile, it may act as a nucleophile, or it may act as a base. So a reaction of Grignard reagent as a base, reaction of Grignard. So I am taking here only Grignard reagent. First, Grignard reagent as base. So suppose if we have RMgX, okay, then in presence of water, so water is having the acidic hydrogen atom, it may act as either weak base or weak acid. So Grignard reagent is one of the strong, it can act as a strong base. So this is strong base, and why it is a strong base? Because it is having the negative charge and this is having the positive charge, so it may act as a strong base, and it may react with the weak acid also. Here this is a weak acid, this is a weak acid, so this will take this one, and what you will get? We get the alkane. So this is one of the methods for the preparation of alkane, and plus what we will get is the Mg okay. Now this Mg having charge +2, this is having charge -1, OH having charge -1, so this charge is neutralized over the magnesium. Now in the same way, this Grignard reagent may react with alcohol. So here this alcohol is also a weak acid, this being the strong base. So what you will get? You will get again, so this will take out this acidic hydrogen atom, this will take out this acidic hydrogen atom, and so we will get here what we will get? We will get OR over here MgX. Similarly, suppose if we have RMgX, it may react with acid. So again, so this R and this H, so we may get alkane and RCOO minus MgX. So the same type of reactions. So I have written the same type of reaction. And even it may react with some terminal alkyne. So terminal alkyne is also a weak base because it is having the acidic hydrogen atom. So if we have this RMgX, that may react with a terminal alkyne. So this is terminal alkyne and it is having one of the acidic hydrogen over here. So but this minus plus this base, this will abstract this proton over here, minus charge come over here, and we have so if we have suppose amine, so one of the acidic hydrogen being present over here, so plus RH minus and Mg is X. So these are the reactions of Grignard reagent with some weak acids. Okay, where you will see the Grignard reagent is acting as a base, strong base. Okay. Now before coming to the reaction of Grignard reagent as a nucleophile, so let's see the preparation of magnesium compound and organolithium compound. So preparation of so first one, preparation of Grignard reagent. Suppose if we see RMgX, so how we can prepare it? So this may be prepared. Suppose if we have alkyl bromide, so this in presence of magnesium and diethyl ether, so this will give R, Mg and Dr. So this preparation, it follows the radical mechanism. So preparation via radical mechanism. Okay, so how the mechanism we can write? Mechanism, if you will see, so this magnesium is having two valence electron, so R Pr plus magnesium is having two electrons, it is quite electropositive, it is having two valence electron which can easily be donated, which it can easily give out this electron, and here by free radical mechanism, so what we can write over here, so this R and this magnesium, this bromine having one radical over this bromine, that will combine with one of the magnesium radical, and one electron will left over the magnesium. So what I can write over here, so this bromine that will with one of the radical and magnesium with one of this radical that will combine to form a bond over here, and one of the electron will left over the magnesium. And in final step, the recombination of this will take place. It will recombine and we will get R, Mg and X. So this is simple radical mechanism for the formation of this. In the same way, if you will see the formation of organolithium compound, so how this organolithium compound may get formed. So suppose if we have alkyl halide and this in presence of lithium, and we take two equivalent of lithium here, and what we will get? We get organolithium compound plus, okay, so if we see the mechanism, then again it will go via the radical mechanism. So lithium having one outermost electron, and this is okay. So this lithium that will transfer its electron completely to it, and that's why it is having now positive charge over here, and here this one of the electron radical over this alkyl radical is formed, and here this bromide ion is formed. And in next step, if you will see, then this radical plus lithium bromide that would be formed here. So this lithium ions, this lithium cation and this bromide anion that will combine to form this one, and again this will combine with one of the another lithium ion, and it will form the organolithium compound. So this is the free radical mechanism via which this organomagnesium compound or organolithium compound can be prepared. Now let's come to the reaction of Grignard reagent as a nucleophile. So this Grignard reagent, it acts as a nucleophile, and nucleophilic, it shows the nucleophilic addition reaction with some carbonyl compound. So for example, suppose if we have suppose any carbonyl compound, it may be, suppose it may be aldehyde, it may be ketone, it may be ester, okay, it may be acetyl chloride. So Grignard reagent reacts with all of these compounds. So if we have, suppose this is our formaldehyde HCHO, and this in presence of Grignard reagent. So this will, here it will act as a nucleophile, and this is the electrophilic center. So it will attack over here, this pi bond that will break out, and we will get and in next step we will this acidic hydrolysis. So or we can say this step is also known as the workup, and after this workup we will get so we are getting here the primary alcohol. So this formaldehyde is giving the primary alcohol, and so here if you see this MgX, we may write here MgX, this, okay, and finally it will give MgOH and this X. Now, in the same way, if you will see, then it may react with either aldehyde or it may react with a ketone. Suppose if this is our aldehyde, or in place of H I may write this R, so it shows the either aldehyde or ketone. So this in presence of RMgX, Grignard reagent, so what it will give, it will react in the same manner. Okay, so after this workup, we will get here so if we have aldehyde, then secondary alcohol that would be formed. Okay, if we are having ketone, then the tertiary alcohol that would be formed. So either secondary alcohol when we have this H, and tertiary alcohol that would be formed when we are having this R in place of this H. Okay, in the same way, this may react with ester also. So if we have ester, then again the nucleophilic addition reaction that will takes place, and okay, and this will give you, this will come back, and this will leave out being alkoxide and being a good leaving group, it will leave out, and what we will get here, we are getting the ketone. And ketone, after, no doubt after hydrolysis workup, we are getting the ketone. Okay, so here I can write, okay, so now, so this in presence of again in next molecule of this Grignard reagent, and this after following this workup, so we will having the tertiary alcohol that would be formed. So we are having the tertiary alcohol. So formaldehyde is giving the primary alcohol, aldehyde is giving the secondary alcohol, ketone is giving the tertiary alcohol, and this ester is giving the tertiary alcohol. And suppose if we are having the acetyl chloride, if we have this acetyl chloride, and this acetyl chloride will also give the tertiary alcohol on reaction with Grignard reagent. Chlorine being a good leaving group, this will leave out in this step, and we are getting the ketone. And ketone again that will react with another molecule of Grignard reagent, and then this after this acidic hydrolysis, so this will give you the tertiary alcohol. Suppose if you are having acetic anhydride, so acetic anhydride that will react with the Grignard reagent, okay, and in next step this pi bond will again regenerate, and we will have this acetate ion that will leave out. So acetate ion being resonance stabilized, so and it will leave out easily, so that's why, so we have is having this ketone, and further it will react with Grignard reagent, to get the tertiary alcohol. Okay, and now suppose if we are having amide, suppose. Now in this reaction, this is a slight different reaction. Now, so in this reaction, here if you will see this reaction, then first this amide, the nucleophilic addition will not take place. Because this amine, one of the NH2 group is present over here, and this amine NH2 group is having one of the acidic hydrogen, and first this Grignard reagent will act as a strong base to extract one of the acidic hydrogen over here, as the acid-base reaction being faster than the nucleophilic addition reaction. That's why first acid-base reaction with this amine group that will takes place. So what you may write, so first of all this acid-base reaction that will takes place, so NH MgX that will form, and here minus RH. So this will act as a base here. This will take one of, it will extract one the acidic hydrogen, and we will get this one. Now in next step, so another molecule of this Grignard reagent, so this will now attack over this center, electrophilic center, and we are having now we may do the hydrolysis. So in presence of this hydrolysis, we will get the alcohol over here and plus NH2, and now the proton transfer, internal proton transfer, this it will take place, and we will get, okay, we will get the so what we may write, so that would be converted into so NH3, that would be leave out here. Ammonia will be leave out, and we are having the ketone, and finally we will having the tertiary alcohol in presence of next molecule of this Grignard reagent, and further workup that will give this thing. Okay, so this amide is finally, it is giving the tertiary alcohol, final reaction. Now some other reaction, if you will see some more reaction with Grignard reagent, then so it may also react with cyclic ester also. So suppose if we have the cyclic ester, that is if it is having the ketone, the lactone, so this is our lactone, that is the cyclic ester. So in presence of this one, okay. Now in next step, this bond will break, this CO bond will break, and we are having here so this reaction is similar to the and this ester, this is open ester and this is the cyclic ester. Okay, and finally so this would be the final product for this reaction. In the same way, suppose if we have suppose it may react with carbon dioxide. Suppose if we have a carbon dioxide, then this on reaction with this Grignard reagent, so that will be converted into acid in this case. So this would be converted into acid and like this. Now, so another one of the important reaction with this Grignard reagent, that is with epoxide. Okay, so if we see the reaction with epoxide, then the reaction with epoxide takes place with the opening of this epoxide ring. Okay, the epoxide ring that will open. So if we have suppose so this is epoxide and reaction with epoxide, it will take place in this way. Now, so nucleophilic addition reaction that will take place here. If you will see, one of the two electrophilic centers are present over here. So one of the electrophilic center, it is present, this is delta minus charge, so this will having the delta plus charge, this is also having the delta plus charge. Now where this nucleophile should attack, whether at this electrophilic center or this electrophilic center. So no doubt here this electrophilic center is the statically hindered center, so this is one of the bulky group is present over here, so that's why it will attack over this electrophilic center and the epoxide ring that will be open like this. Okay, so the product in this case that we may write, so here this will get open and we have and so from at this carbon, one of the this R that is attached over here, and in further hydrolysis, so it will give the alcohol. In the same way, suppose if I have epoxide ring, which is suppose and one of the methyl group is present over here. Now, so for this one, from where this, if we see the stereochemistry in this case, then from where the this nucleophile will attack on this one. So if you will see, then this one, this carbon, this is one of the electrophilic center, this is the another electrophilic center. Okay, so the carbon and this alkyl, okay, this nucleophile will attack over this center and this will open up, and finally, so if you will write, then this opens, and this is oxygen which is having the minus charge. This is the one of the alkyl group is present, methyl group is present over here, and now this R as a nucleophile will attack from the lower side. This is above the plane. This will attack from below the plane. So that's why I should write this should attack from below the plane. And the finally after this hydrolysis we will get this product. So this would be the final product in this case. This would be the final product. Okay, so these are some of the reactions of Grignard reagent, with some of the carbonyl compound. And now in the same way we can write the reaction of this organolithium compound. Suppose if you want to write the reaction, mostly the reaction that remains same. So reaction of organolithium compound with the carbonyl compound. So if you will see, as nucleophile. Okay, so suppose if we are having any aldehyde or ketone, then so again here in this case it will act as a nucleophile. This is electro, and it will act, and this is delta negative charge, this is having delta positive charge. It will have nucleophilic attack over this electrophilic center, and pi bond will break, and it is O minus Li plus. And finally again we will having the hydrolysis, and either secondary alcohol or tertiary alcohol that would be formed. So if we have aldehyde, then secondary alcohol. If we are having the ketone, then tertiary alcohol. So if H is there, then we are getting the secondary alcohol. If R is there, then we are getting the tertiary alcohol. Okay, so reaction is quite same as that of this magnesium compound. Now suppose if we have a ester, so we leave out, and we are getting the, here we will get the ketone, and this ketone further in presence of like this. Now the reactions are same as that of Grignard reagent. So one of the reactions, suppose this organolithium compound that reacts with carbon dioxide in this case. then this reaction is a little bit different than that of organomagnesium compound. So here it will again react with this organolithium compound RLi. So because this organolithium compound are very much reactive, so that's why it will again react with this one. And finally, so this ketone get formed here, and then in next molecule of organolithium compound and this one, so it will give, finally that will give you the tertiary alcohol. Okay, so this is about the organometallic compounds. Okay, thank you.